Okay, so we were talking about fake news, and we said that we will discuss a few papers related to this topic. And the first one that we are going to talk about, I already gave you a hint last day. So this will be about fake news, early detection, and interdisciplinary study. And this was by Zhou, Chen, Hoha, and Zafarani. So this paper actually tries to uh, like develop an end-to-end pipeline for detecting fake news using a supervised framework. Now, like their problem definition is as follows. So you have a news article that needs to be verified. Okay, so this is there is a news article, say incoming news article, which needs to be verified. And say you extract some features representing this news article. Okay, so now the problem definition reduces to the following. So let's say these features are represented by f. Now you want to learn a function a, okay, where f k yk is a set of or a pair of items, okay, comprising what is called the training data. Okay, and the y hat is a 0, 1 level, where 0 refers to not a fake news and 1 refers to fake news. Okay. Similarly, like as we have already looked into this kind of frameworks earlier also, okay, if k belongs to a real space Rn and yk is drawn from the label space 0 and 1, okay, and there are a finite number of data points from which you want to learn your function or the parameters a. Okay. TD in the form of feature vectors and label pairs in the form of feature vector and label pairs. Okay, this is how you feed the training data, and you want to, your objective is to learn A. Okay, so now, so this is a standard supervised machine learning framework. So why did the authors go for this kind of a framework rather than a like very sophisticated deep learning architecture? Why did the authors go for this kind of a simple ML setup? The reason to this, like as suggested by the authors, is that these models that they develop are explainable. So basically, you can actually pin down like what features are responsible for the like detection of the news article as fake or true. Okay, so what are the features? Which features are more important? Which features are less important? So all these things can be easily understood using this kind of an ML setup, which is difficult in a DL setup, in a deep learning framework, because it's more like kind of a black box. So this is one thing. And the second thing is that in this kind of systems, data is low. Okay. And since data is low, it is difficult to train highly data hungry DL algorithms. So these are the two specific reasons for which the authors went for like a regular ML setup rather than a sophisticated DL setup. Okay, so now their preliminary idea of developing this entire pipeline is based on the Andauer's hypothesis that we already looked into in one of the previous lectures. Which tells that fake news is different from true news in terms of quality, in terms of quality and writing style. Okay, so this was one of the things that we already had a small idea about when we were discussing about the Andauer's hypothesis. So here, and we talked also about like the style based methods of detection of fake news detection. So this is a particular method which is based on this style based like idea of fake news detection. So basically the authors captured the linguistic style at three levels. The first level is the lexical level, syntactic level, and semantic level. In fact, they also have a fourth one, which is the discourse level. As you will see, like later on, these are more important. So we'll see when we get to the results. So now, first, the lexical level. So as the name suggests, this has to do with the words present in the news article. Okay. So basically, what the authors try to do is to count the frequency of words. Okay. But these are normalized appropriately. You have already heard earlier, probably in some of the other courses that you have attended. So this is like a bag of word model. So what is standardization or normalization referring to here? So basically, let us say that you have a corpus of P articles represented by the set M. So these are your P articles. Now let's say the total number of words in these P articles is Q, and this is represented by the set okay. Now let us say X ij is the number of words of Wj appearing, sorry, number of words Wj, not of Wj, number of words Wj appearing in the article Mi. So then the normalized or standardized frequency is given by so you are computing the normalized frequency per, so within each article, the normalized frequency of a word J. Okay, so this is what you are computing. Now, So this is one way to measure the like the bag of word model, to compute the bag of word model. So, but there are like certain improvements on this that one can make. Can you think of one?
Add one.
Huh?
I mean, we count. We can plus one, and we in that.
Oh, so that is a smoothing. But
Yeah.
anything else like some better bag of word model than this one? So what is this measure closely related to in IR or in NLP also? What is TF?
Term,
Anyone knows what is TF?
term frequency.
The term frequency. So the authors are predominantly considering the term frequency. So that's why I was asking, would there be anything better?
TF-IDF?
TF-IDF. So this could be an alternative. So now when I am discussing the pipeline, at many points you will see that I will be discussing alternatives that could have been taken. You can also try to think of this kind of alternatives, because that like would allow you to handle this kind of projects in a much better way. So this is an alternative. Okay. So the next is the syntax level. So how do you typically measure syntax? Or what are the signals of syntax in natural language? What are the different measures of syntax? What is this?
Part of speech tag.
Parts of speech. So this is typically known to be a shallow indicator of syntax. Okay. And anything else?
So dependency parsing.
Yes, dependency parsing or some sort of parse tree.
Parse trees, yeah.
Yes. So the authors used rewrite rules obtained from. So yes, Hardik, you are correct. You can use dependency parsers, but they used PCFG, probabilistic CFG. Okay, so they used part of speech and the PCFG to derive the rewrite rules. So for each of this, what they did. So before I go to like the exact definition of the features, like for those who are not aware of rewrite rules, let us take an example and see how the rewrite rules are constructed. So the authors used the Stanford parser to obtain both. So suppose you have a sentence like this: the CIA confirmed Russian interference in the presidential elections. Okay. So if you have a sentence like this, then using certain tools, NLP tools that are already available, you can construct a parser like this. So in this way, you can parse every sentence to get a parse tree like this. Okay. So each of these symbols have their own meanings. So DT is the determiner. Okay. NNP is the proper noun. VBN is a verb form. JJ is a qualifier. NN is a noun singular. And NP is the noun phrase. PP is the prepositional phrase. Okay. And then again, under that, you have the preposition, a determiner, a qualifier, and another noun. Okay. So now from here, the rewrite rules are as follows. NP produces DT, NNP, VBN, JJNN, PP produces INNP, NP produces DT, JJNN, DT. So in this way, you can have rewrite rules. So now, similarly, as you computed the standardized or normalized word frequencies, here you compute the normalized pause counts and normalized rewrite rule counts. So basically, here you compute the different types of pause, like nouns, verbs, qualifiers, etc. Okay, so you count each of them and normalize by the total number of such POS tags. Okay, similarly here you count the total number of rewrite rules and you have number of rewrite rules of a particular type divided by the total number of rewrite rules. So in this way, you compute the normalized POS counts and the normalized rewrite rule counts and include them as features. So this is all about the syntax level. Now comes the semantic level. So this is a very elaborate level. As you can understand, most of the fake news like component are hidden in the latent semantics of the news article. So that's why the semantic level is very important. Okay. So now this level actually is dedicated to identify psycholinguistic attributes. We will see how we do it. Linguistic attributes, sentiments, okay, opinions, informality, and many other such points. Now, the authors divide the sentiment analysis of the total content of the news article into two parts. One is the sentiment analysis of the news headline, and the other is the sentiment analysis of the news body. Now, as we were already discussing last day, that news headlines can contain lot of indications of whether it's a fake news or not. And one of the strongest indications is whether the headline is a clickbait or not. So basically, you want to find out that whether the news headline has a clickbaity nature. So what is a clickbaity nature? So clickbaity nature has certain phrases which attract a lot of eyeball from the reader, from the news reader. Okay, so some of these are as follows, like can change your life. So in the headline, they will have this kind of messages: will blow your mind, etc. Okay. So what do we do? So they do two things. One is they identify general clickbait patterns in the headlines. Okay. In order to do this, what they use is a dictionary of clickbait phrases. Okay. Now, using this dictionary, they find out whether a particular clickbait is or a particular phrase is present or not. Okay. So, like they do not identify the number of such clickbaity items present in the headline, because in general it's not so natural to have more than one such phrase in the headline. So that's why they don't go for a count, but they just go for a boolean flag whether clickbait clickbaity phrases present or not. Okay? So they do a dictionary check. The second thing that they do is kind of more interesting. So basically, uh, so as I was telling you that uh, earlier psychological and psycholinguistic literature have shown that clickbaits tend to attract a lot of eyeballs, and basically that's why people click through them, and that increases the total number of click-through rate or the total amount of click-through rate for a particular news article. And this is something that fake news articles are always after. So basically, the more number of click-throughs, the more like reach they get, and more people read about the fake news. Okay, so that's why this the kind of expression that is there in the headlines uh, is important. Okay, and this is measured as how readable is the content of the headline. Now, what does this mean? So basically, if you see a clickbaity headline, you get attracted to click it because there is an information gap between your knowledge and what is being talked about in that headline. So, so there is an information gap between the presented headline and the reader's knowledge. Right. And this information gap can be captured by measuring how readable the headline is. Now, if it is very readable to us, that means there is nothing so startling, nothing so attractive. But if it is not so readable, it's hard to read, then it's probably more attractive and more sensational. So that's why this is measured by the readability index. There are different types of readability indexes that are available in the literature. The most famous one being the Flesch Reading Index. And then there are further variants. Etc. So we will not go into the details of this. If you are interested, you can look into Wikipedia, and there are good amounts of information for all of this. But the basic idea is that, like, these were tests that were performed to identify the readability ease of certain texts given to different grades of students, like starting from preschool, middle school, high school, and so there are graduations. And this readability index like spit out a score, and based on the score, you get to understand whether the sentence is readable. Like if the so based on the value of the score, you identify the difficulty in the readability of that particular sentence or groups of sentences. Okay, so that's the idea. So basically, if the readability index is better, then that means there is not much attractive in the headline. However, if the readability index is low, that is like the readability is hard, then there is something that is attractive in the headline, and this mismatches with your common knowledge. Okay, so that's what the authors tried to capture using the readability index. Then the third thing that they tried to capture was sensationalism. So recall that all these are happening on the headlines. Okay, all these measures are happening on the headlines. Okay, so sensationalism. Now, under sensationalism, they study three things. The first thing is sentiment. So, uh, tell me, what do you think about uh, sentiment differences between a fake and a true news? Some very straightforward sentiment differences that you can think of. What type of sentiment words would be more prevalent in fake news? Especially like the headlines. Think from the perspective of a fake news. First of all, tell me, do you think that news items should be full of sentiments in general? Do you think that the news
No, sir.
reporting is full of sentiments?
Um, it probably is full of sentiments, but it shouldn't be.
So, in general, it is full of sentiments.
Um, like the video reporting usually has sentiments, but the text reporting doesn't.
Okay, so very good. So basically, what you are trying to say, if I can summarize, for true news, it's mostly factual. Okay, so basically, they follow something called the NPOV guideline. That is, this is also followed in Wikipedia, neutral point of view. What about fake news? Any fake news that you have come across, or a set of fake news that you have come across in general? Okay, there might be very carefully contrived fake news, but in general, anything special about fake news in terms of sentiments? So they typically, especially in the headlines and also in the body, they would typically express extreme sentiments. So say some presidential candidate is excellent, very good, and things like that. Okay. And this has been supported by so and so organization very strongly. So all these words like good, strongly, etc. will come in. So they would express extreme sentiments, okay, either positive or negative. Now the authors measured this negative and positive words count. I mean, they compute the normalized number of positive and negative words, and this is obtained from a dictionary called the LIWC. Okay, so this is linguistic inquiry and word count dictionary. Okay, so this dictionary, what it does is it hosts a large number of different types of words subdivided under different categories. Okay, and like you pass your document through this tool, and the tool tells you, like the tool counts, like the counts and normalizes the different types or categories of words. Say for instance, like how many positive sentiment words, how many negative sentiment words, etc., etc. So all these are counted and returned. So that is like something that the authors use as a signal for identifying fake news. So their idea is that the larger, there will be a larger fraction of positive and negative, or strongly positive and negative words in the headlines of fake news. Okay. The second thing that they look for is punctuation. as I guess you guys have also observed, that in this kind of clickbaity headlines, certain types of punctuations occur very frequently, like triple dot, question mark, exclamation. So they count this special, the occurrence or the number of such special like punctuations, and use this normalized count as a feature. Okay. The third one is similarity. So now there is a clickbaity headline, and there is a news body, and say there is a factual headline, okay. Now what can you comment about the similarities of these two items and these two items? Suppose I call it A, B, A prime, B prime. So which one do you think would be more similar? A, B would be more similar to each other, or A prime, B prime would be more similar to each other? My question is, would A and B be more similar to each other than A prime and B prime? Or is it the opposite case? What would be your take?
Sir, A prime and B prime will be similar.
Very good. So A prime and B prime will be more similar, because the doctrine of news reporting actually tells that the news headline should be an appropriate summary of the news body. So a factual news headline would be really a nice summary of the news body, which would not be the case, which would not be true for a clickbaity news headline. Okay, it would be most often different from the body of the news. Okay, so therefore the authors, what they do is they compute vector representations. They compute the vector representation of the news headline and the news body, and they measured the cosine similarity. So obviously the cosine similarity will be higher for the second case compared to the first case. Now question is, how do they represent these as vectors? So they used word to vec. okay, and also used sentence to vec. So in the word to vec, they took the representation of each word in the headline and averaged them to get a compressed representation or an aggregate representation of the whole headline. And in the sentence to vec, they pass the whole headline to get the representation. In both ways, they measured the cosine distance or the cosine similarity between the vector representations and used this as a feature. Okay, so we'll stop here, and next week, like tomorrow and the day after, we will have invited talks. Next week, we will talk about the rest of the features and also discuss the results that the authors obtained.